Okay, welcome to my video explanation of the quiz problem. This was the problem of Kyle and Connor on their trip across the Pacific Ocean trying to get to Japan. The problem states that they are leaving Seattle, which is here, and heading north 99 degrees west. So we start north, we go 99 degrees. That's pointing us roughly in this direction, sort of headed toward Japan at a speed of 4.2 miles per hour. Okay. Well, 99 degrees from north, we want to put that into standard position before we try to convert this vector into component form. So 90 to 90 degrees from the north is 100, 99 plus 90 is 189 degrees in standard position. So before we use cosine and sine, we need to put ourselves into standard position. So the vector of the boat without using the current at all would be 4.2, which is the magnitude, 4.2, times the cosine of this angle in standard position, measured from the positive x-axis. 99 degrees from here is 189 degrees in standard position. So I use sine and cosine to give me the x and y components of that boat. And so the boat vector should come out to be, when you do this on your calculator, if you're in degree mode, you should get negative 4.148 for the x component and negative 0.657 for the y component. Now, a couple of quick things. When you're done with your vector, look at that vector and make sure it really makes sense to your problem. If they're headed from here, they're trying to get to Japan, does it make sense that my negative component is negative 4.8, 4.1, and my y is negative 0.6, is about down here? Yes, this vector is pointing me toward Japan. They were headed in the right direction. Unfortunately, we have this current vector, and the current is pushing them at north, so I'm going to erase this to come up with my current vector. So my current vector is starting at north, going 164 degrees to the east, so it's pointing down here. Well, again, we want to get that in standard position, so there are a couple of ways to do that. Probably the easiest way is to simply say, okay, well, I don't want to start here and go 164 this way. I want to just go from here and go down from the x-axis. So instead of being 164, I take away 90 from that. So that comes out to be 74 degrees. And that's a negative angle because it's pointing me down into the fourth quadrant. So that would be negative 74 degrees. So if I take the current vector, the magnitude of that is 0.4, so I'd go 0.4 cosine of negative 74 degrees. And that would be my x component. And then 0.4 sine of negative 74 degrees. That would be my y component. And that comes out from my calculator. I got 0.11 in the x and negative 0.3857. 3.85 in the y. You'll notice a couple of things here. In the end, my answers are all going to be rounded to the 10th decimal place. But when I'm doing these intermediary calculations, I'm giving myself more decimal places so that when I do my final answers, I'm not losing accuracy. So even though I'm going to round all my answers to the 10th at the end, hold more decimal places as you work so you don't lose that accuracy as you finish up here. So now, the boat is kind of headed in this direction toward Japan. The current is sort of pushing down, along the coast of California. And so the resultant vector is going to be the sum of these two vectors. I take this x component, and I add it to that. That means we're essentially slowing the boat down in the sort of the westerly direction. And then these two add together means it's being pushed down and toward the south quite a bit more. So my resultant vector, the vector b plus c, the vector that I got there was negative 4.038, comma negative 1.042. Again, I think about that vector, I see if that kind of makes sense to me, and it does make sense to me. Now I want to convert this into direction and angle, magnitude. So the magnitude of that vector, it's pretty easy to do, provided I don't get messed up by the negatives. I'm going to square this number. Now if you put that in your calculator and you type negative 4.038 squared, the calculator is going to square that number, make it negative, and it's going to give you the wrong answer. So it'd be smarter for you just to forget the negatives. You know that when you square these, And when you calculate the square root, this thing's square, the negative should just go away. So why not just drop it and remove that possibility for making a mistake? So I'm calculating this on my calculator, and the magnitude that I got was 4.17, and my units are in miles per hour because 4.17 miles per hour. They were rowing at 4.2 miles per hour, but unfortunately the current is sort of pushing against them a little bit, so it's actually slowing them down. So that's the 4.17 is the miles per hour. To find the angle, I'm going to use the tangent. So the tangent of the angle is the y over the x. So it's negative 1.042 divided by negative 4.038. I'm going to take a tan inverse on my calculator. The calculator, of course, is going to have me pointing into the first quadrant for this angle. So the angle I get is not the angle I want. It's pointing me into the first quadrant. I know that I really want to be pointing down here into the third quadrant, so I convert that into, by adding 180 degrees to it. So when I add 180 degrees, let me show you what I get here. The angle that I get, I will erase all of this. The angle that you get when you do this is pointing up into the first quadrant, but I want to add 180 to that to get me down into the third quadrant, and then I really want to give the angle from north. So what I do is I do this on the calculator, I get this, I'm going to take this angle, I'm going to add 180 degrees to it, puts me into the third quadrant, and then subtract 90 from that. So I really only wanted to add 90 to it. And so the angle I get is 104 degrees from here, 90, and then 14 degrees more. That's north, 104 degrees west. So because I gave in the problem, I gave these as bearings, it makes sense to give your answer as a bearing. Now if you had left your answer in the third quadrant in standard position, I would be okay with that provided you tell me that your answer is in standard position. But this is probably our best angle here, 104, which is the same thing as a standard position of 94, in standard position. This would also be a sufficient answer, 194 in standard position. And so that means I'm going sort of to 180, I'm going 14 degrees more, and the question is, where does that get me when I actually draw that on the map? So now I'm going to need my handy-dandy protractor to do that. So let's bring up our protractor here. So here's my protractor. I'm going to grab onto this thing, going to put it right here at Seattle, where we're starting. We are heading 14 degrees, so let's see if I can come up with a line here. So we're starting here, and we're going, there's 10 degrees, there's 15 degrees, so that's 14 degrees right there. So when I did this, I got, I'll get something different here when I do it on the, oh, I didn't start at Seattle. Okay, so, sorry, let's do this in there. Okay, yeah, I get right here. This little island off the coast here is the island of Taiwan, sort of the independent nation state of Taiwan, which is where they're going to end up if they follow that. I calculated the distance across here using the Pythagorean theorem, so I made a right triangle, -6, about 1.5, and I came up with a distance of 5,875 miles. They are traveling at a speed, with the wind, their speed was 4.17 miles per hour, remember. When you divide this by this, it is going to take them 1,408.9 hours, which is 58.7 days. I hope they bring plenty of food and water with them. There you go.